Hello, and this is a tutorial on how to do problems in physics. And what you see here on the screen is just a sample problem that is given in one of the workbooks. This happens to be Holt Publications, and it's a physics book, of course. So here what it gives is we have the problem given in detail here, written out. Now remember that all physics problems are word problems. So what we have to do is we have to be able to organize it, and that's what this tutorial is. How do we organize one of these type of problems so we can get through them and keep them organized, okay? So here it talks about the solution. So this is all the steps that we have to do for doing a solution. We've got to get the givens, we've got to have an unknown, and then we solve. So I'm going to show you another kind of a graphic organizer that you can use to solve a particular problem. So what we're going to do is we're going to look at problem number 2 here. Okay. Problem number 2 is this one right here. It says, in 1935, a French destroyer, La Terrible, I don't speak French, so I tried my best on that one, attained one of the fastest speeds of any standard warship. Suppose it took 2 minutes at a constant acceleration of 0.19 meters per second squared for the ship to reach its top speed after starting from rest. Okay, so that's an important portion right there. Calculate the ship's final speed. All right, so that is the problem. So what we're going to do is I'm going to show you our standard format that you should probably be using in order to do this particular problem. All right, so first of all, this particular paper, you don't have to get this paper. It can be on any kind of lined paper or anything like that. It's just, this is one of my favorite types of paper to use. Got accustomed to it in college and stuff like that. All right, so we should always have some kind of a heading up here at the top, and this is just, for this particular case, I'm just going to call it problem solving. Problem solving. And always, always, always put your name on your papers, okay? I'm just going to put my last name here. All right, so Chisholm. Now, what I want you to do is, of course, number it. So you could put it in the margin or put it on the side, whatever. So this is number 2. Then start off drawing a box, okay? And what this is going to do is this is going to contain your messy writing, and a lot of you know what I'm talking about, messy writing. Some of you are super neat, super fastidious about it, then okay, you're fine. But a lot of you are messy and you kind of run into each other, you know, run into one problem into another and stuff like that. So this is going to kind of contain you a little bit. All right. So I start off with putting these 2 lines here. It's work. You know, this process has worked for 15 years. I've been showing my students to do it, and I have several students during the school years, every year, that do keep maintaining this, and their papers are very easy to read, very nice for me to go through and find the answers and correct it and stuff. Okay, so in this area I'm going to change a color, and I'm going to go here. You don't have to change colors, it's just for you to see what I'm doing. Okay, I'm going to call this particular area right here, this is going to be the givens area, and I'm going to underline it so I know. And in the givens, we're going to go through and look at the numbers that are given to us and the labels. So first one right here, as I read through this, was 2 minutes. So this is a time, okay? So T equals 2.0 minutes, M-I-N. Okay. And then the second number on here was 0.19, and that was an acceleration, 0.19 meters per second squared. Now, we haven't gotten to acceleration yet, but this is about solving problems. This isn't about the problem itself. You might see it again later. Okay, and as I look through this, there were no other problems. So what I'm going to do is I'm going to close this particular box right here. So I'm going to make a closure there, and then in the case up there it said unknown. Well, you can use several different things. You can say equation, unknown, use a question mark, whatever. It doesn't matter. Just label it so you know what that is. Okay, and I'm going to write this as I did in my a document that I put in your Canvas that indicates that this is where you're going to put your equation. This is where you're going to put multiple equations. If you need multiple equations, you're going to put the final equation that you're going to use to solve the problem here. In this case, it was asking for final velocity. Velocity final. And velocity final is going to be acceleration times time plus the initial velocity. And then we're going to close this particular box. Okay, it doesn't extend any further than what you have here, so what we're going to do is we're going to finish boxing that. Okay, and then I'm going to continue this line over. And this might be a weird thing, but it's going to be necessary at a particular point, because what we're going to put in here, we're going to put a drawing. So I'm going to write here, just draw. Okay, you're going to draw a picture. At first, the picture is just going to, it's going to be just added work. It's not going to be anything that you're going to necessarily need to solve the problem. But later it will be extremely important that you have it there. When we get to vectors and things like that, you have to be able to, you have to draw the image to see where things are located. But in this particular case, you're going to make a drawing, and in this one it said that it was a warship. So what I'm going to do is I'm going to make a ship here. This was in 1935, so this is going to be a probably a steam-driven boat. So there's going to be smoke up here and stuff. And you know, I'm just going to tell you right now, you know, many of you are artists, and all I want you to do, if you're an artist, do a quick and dirty job of drawing it. If you're not an artist, do the best you can, but do it fast. You don't have to take your time to do it. Okay. I know artists get very fastidious about it, and they have to spend a lot of time here. Then the last box down here, this is where you're going to solve the problems. Okay, so I'm going to write the word solve here and underline that. Now, before I solve, I'm going to look at this and I'm going to say, all right, I need meters and I need seconds. But here, this is minutes. And minutes and seconds do not mix. They're not the same thing. So I need to change my minutes here into seconds. So I'm going to use dimensional analysis. You guys had this in chemistry. Dimensional analysis, it's a wonderful tool to do conversions. Okay, so I'm going to use dimensional analysis here to do the conversion. You start off with your given, which is 2 minutes, and then we're going to convert it minutes into seconds. So we have 1 minute is 60 seconds. Now, some of you can do this in your head, but that is not showing work. You need to show your work. So this is showing my work. Minutes cancels with minutes. I'm left in seconds. This is a 1, so we don't have to worry about that portion. So we have 2 times 60, and we get 120 seconds. Now I'm ready to work with this equation here. So that's multiple equations that we're dealing with. So there's one equation there. And then I'm going to do velocity final. I already have the equation written here, so I don't have to rewrite it here. Only do that if that is necessary for you to do it. But you could put in your numbers. So 0.19 meters. Now, we can use dimensional analysis here, and I always use dimensional analysis because it is a fantastic tool, and it keeps me straight with what I'm doing. Okay, that's meters per second squared, so the divisions, the pers, go in the bottom. And then we're going to multiply by time, and our time was 120 seconds, so 120 seconds. And then we're adding the initial velocity, but in the question it said that it was starting from rest. Rest is 0, so I do not have to have that there. Okay, I can justify it up here at the top by crossing it out and putting a 0 above it. But you have to justify it. You cannot just cross things out to cross things out. They have to be justified. Okay, and that one's justified because it's starting from rest, and it said it in the problem. Okay, so now I've got my seconds here cancel. One of the seconds here cancel, so I'm left with meters per second. Now I take out my handy dandy calculator, and I am going to take 0.19 and multiply it by 120. Okay, so 0.19 times 120, and I get 22.8. So then my answer here is velocity final equals 22.8 meters per second. And then I am going to put a box around it because this indicates what my answer is. Then finish your other box. All right. Now, this is one problem. Now I would go on to number 3, and I would put number 3 right down below it here. Do another box here, and I would do it all over again. Okay, this keeps it nice and separated. You could put number 3 here if you want to. However, sometimes maybe these things get a little bit longer and they do move over into this area. I have seen so many different things over the years that they merge into each other, and it's kind of hard to tell one problem from the next. That's why I want you guys using this technique in order to organize so we can see, so they don't merge into each other. Okay, now givens, equation, or unknown, and solve. This is exactly the way this goes. Given, unknown, solve. Okay, it's the same process. The only thing that I've added to this is the drawing portion. All right, so this is your tutorial on how to do this, and every single problem will be done the same way. If you have more equations that you're using, you're going to have more areas to solve, so this box will extend down lower. That's why you don't close it until you are done. Okay, and make sure your final answers are the ones that you box. Either box it or you write a sentence. The speed of the Le Tablet, or whatever, however you pronounce it, was 22.8 meters per second. And then you box that. Okay, so it doesn't matter. It's a word problem. It should have worded answers. But if you do it this way, this is all showing your work. No work, no credit. Okay, I want to make that perfectly clear, and I'm going to say it several times during the school year. No work, no credit. But this is your tutorial on how to solve these problems. Thank you.